Hi everyone, and welcome back to Maths and Physics, Mr. Simons. Today this is a grade 11 analytical geometry problem, and we're looking at rhombus related exam questions. I'm going to go through various shapes because we use different shapes and their properties trying to catch you out with analytical geometry. Alright, so in November 2012, just before CAP started, gave ABCD as a rhombus, with A being 3, -3 and 8, C being 5 and -4. Diagonals of A, B, C, D bisect each other, so those two diagonals bisect each other at M. The point E, 6 and 1, lies on BC. Alright, so 5.1, calculate the coordinates of M. M is a midpoint, so you should be able to do that. Calculate the gradient of BC, so there, though we don't have the coordinates of B, you should see that E and C are on the same line as B, so they're collinear, so the gradient of EC should be the gradient of BC. 5.3, determine the equation of the line AD, so there we have AD, the form y equal mx plus c for 3 marks. Then 5.4, determine the size of theta, that angle there, show all calculations. Alright, so you can pause here and attempt to answer it. Then you can go through the corrections that I've done to see where you've got wrong. And then redo it again till you don't make the error. So 5.1, calculate the coordinates of M. So the diagonals of the rhombus bisect. So therefore they share midpoint. I have a coordinate A and C, so using the midpoint formula I should be able to find the coordinates of M. So A there is -3 and 8, and C is 5 and -4. Midpoint of AC, x1 plus x2 over 2, y1 plus y2 over 2. So -3 plus 5 divided by 2, 8 minus 4 divided by 2. 5 minus 3 gives me 2, 2 divided by 2 is 1. 8 minus 4 gives me 2, 2 divided by 2 gives me 2. So there's the coordinates of M. 5.2, calculate the gradient of BC. So we want BC. Take note, they've given me a point A. So they are all on the same straight line, therefore they are referred to as being collinear. So if I use point E and C to get the gradient of Eastern Cape EC, I automatically have the gradient of BC. So gradient BC equal gradient EC, they are collinear points. So E being 6 and 1 and C being 5 minus 4, gradient y2 minus y1 divided by x2 minus x1. So from there, 1 minus 4, and please don't get caught out to the signs. See there 1, the minus is already there, minus 4 in a bracket. So 1 minus 4 divided by 6 minus 5. So that becomes 1 plus 4, which gives me 5. And 6 minus 5 gives me 1. So 5 divided by 1 gives me 5. So the gradient of EC is 5. Then the gradient of BC equal 5. Alright, so that's just catching out with collinear points. 5.3, determine the equation of line AD in the form y equal mx plus c. So the shape is the rhombus. We want AD. We just found the gradient of BC. No? So in the rhombus, BC and AD are parallel. So they parallel, the gradient of BC must be equal to the gradient of AD. So therefore, AD parallel to BC, they are opposite sides of a rhombus. So gradient AD equal gradient BC, which equals 5. So if I substitute in the equation y equal mx plus c, then y equal 5x plus c. On this line, I only have one point A, which is -3 and 8. So according to this, y is 8 when x is -3. So I have 8, 5 times -3 gives me -15. If I take it over, it becomes +15. 8 plus 15 then gives me 23, therefore my C value would be 23 and y equal 5x plus 23. So this line AD, if we continue drawing it, it will cut the y-axis at 23. Right, so I hope you're with me, you follow what I've done. Let's look at the last question. Right, 5.4, determine the size of theta, that is PAC. Show all calculations for 6 marks. So we should know ABCD was given as a rhombus. So therefore AB must equal PC must equal CD equal that. So all four sides are equal. So if that angle there is theta and these two sides are equal, then this angle here is also theta. Alright? Now, so if AB equal PC, PCA equal theta. Alright? Now, see the ARS forms the exterior angle of a triangle. So we should know the exterior angle of a triangle equal the sum of the two opposite interior angles. So this angle RSC plus RCS together must give me the exterior angle of that triangle. So because I have ARS, I can use the tan of ARS and the gradient of AC to find this angle. Alright. Then for PST, you see the PST, to find this angle here on the outside, I can also use the gradient of PC. You should see this angle and that angle are vertically opposite. Alright, so I hope we're together so far. So this is one of those questions we enjoy, testing exterior angle of a triangle. So yeah, when I say PCA, this angle theta, equal ARS, the outside angle, which is the bigger one, minus RSC, this angle there. So as I said, tan ARS equal the gradient of AC. So we take the points there of AC, 8 and negative 3 and 5 and negative 4. I have 8 minus 4 minus 3 minus 5, which then gives me a gradient of minus 3 over 2. Gradient of PC we found in the previous problem, so the tan of PST equal 5. Right, so if we punch this in, shift tan minus 3 over 2, we get negative 56,309. So therefore we say 180 minus that, and it gives me ARS 123,69. So this angle here is 123,69. Say shift tan 5, I get PST equal as 78,69. So this angle here on the outside, 78,69. Therefore this one is also 78,69 due to vertically opposite angles. So 123,69 and I have 78,69. So theta equal 123,69 minus the 78,69, which then gives me 45 degrees. So theta there is 45 and that is 45. Right? So that is calculating it for 6 marks. Alright? Hope you understand. I hope you enjoy the lesson. Please like and subscribe. Continue practicing. As I said, I'll try to do as many shapes and I'll try to do as many examples as possible. I hope I can help you improve your maths and increase. To God be the glory. Goodbye.